which you know is always going to be what? Negative b over 2a. That's the x-coordinate of the vertex. So in this case, a is -1 and b is 5. So x is going to be what? Negative over 2 times, and you end up with 5 over 2. So that's the x-coordinate of the vertex. How do you find the y-coordinate? Plug it in. So you need to do f of 5 over 2. It's going to be negative 5 over 2 squared plus 5 times 5 over 2 plus 3. So yeah, it's fractions. It's not going to be impossible. So what do you end up with? Negative 25 over what? 4 plus 25 over 2 plus 3. We need what to add fractions? Yeah, so you have negative 25 over 4 plus 50 over 4 plus how many fourths are in 3? 12 over 4. Add these two together and you end up with 25 over 4 and so what do you end up with? So what is the vertex therefore? What is the vertex? 5 over 2 comma 37 over 4. There's your vertex right there. Or down. Opens up. Why? Since what? Does not open up. Look at the original equation. Does this open up or down?
Down.
It opens what? Down. Since what is true? Since what? Opens down. Since a is less than 0. Correct. Correct. So we just did the second. Yeah. It's moved to the right. How much? 5 over 2. And does it go down or up? What? Up how much? Yeah, exactly. It tells you this is the new vertex, right? It goes to the right and it goes up. Excellent. Okay. And is it wider or narrower or the same shape as the graph of y equals x squared? What do you think? Same shape. Why? Yeah, the coefficient is, it just flips. It's just a is -1, so it doesn't change how steep or narrow it is. It just flips it over. And then what do you do? If it is a parabola with vertical axis, find the discriminant and use it to determine the number of x-intercepts. So find that. What is the discriminant? The discriminant is b for ac. So in this case, remember what was b in with a, b, and what was c? 3. So you take these 3 values right here, and where do you plug them into? Bless you. You plug it in down here, exactly. So, bless you. You get 5 squared minus 4 times -1 times c. What does that come out to be? 25 plus what? 12. So that's equal to 37. So how does the discriminant tell you about the number of x-intercepts? 37 is what? Greater than 0. Therefore, that's what the 3 dots mean. How many solutions do you have? You have, no. How many times can a quadratic cross the x-axis? Once, twice, or 0. So how many times is it? It's greater than 0, so how many times is it going to cross? What? Okay, we need to review this. You guys are just yelling out randoms. Review this. If the discriminant d is greater than 0, what do you have? 2 real solutions. If the discriminant is equal to 0, you have 1 real. And if the discriminant is less than 0, you have 2 imaginary. So what is the discriminant in this case? 37. The discriminant is 37, which is a positive real number. So therefore, how many solutions are there? And are they real or imaginary? Real. And then it says, find the discriminant and use it to determine the number of x-intercepts. So how many x-intercepts? So 2 real x-intercepts. Good. Does it ask you to graph this? I don't think so. What's a great thing to find first? Vertex, right? And we know the vertex is equal to -b over 2a, comma, f of -b over 2a. So we find a, b, and c first. What's a, Rachel? What's b? And what's c? We might use c later. So x of the vertex is going to be -b, so that's negative what? 4 over 2 times what? So that's going to be -4 over -4, which is? That's nice. So what's f of 1? -2 times 1 squared plus f for 1 plus minus what? Minus 5. So that's going to be -2 plus 4 minus 5. It's going to be 2 minus 5 is? -3. 2 minus 5 is, yeah, you got to do 2. So what's the vertex going to be? 1, -3. So do we have the vertex? Yep. Does that mean it's going to move left, right, up, or down? It's going to move right 1 and what? Down 3. And then overall shape. What does this -2 tell you? It tells you two things. It's flip and it's twice as steep. So let's start by going to 1, -3. If we go to 1, -3, let's go to 1, -3, it's right there. There's 1, -3. We know that's the vertex. And it's going to go up or down? Down. So you could make a table if you wanted to. It's twice as steep though. So instead of going 1 over and 1 down, you're going to go 1 over and how many down? What? 2 down. 1 and 2 down to here because it's twice as steep. Twice as steep. What's 1 squared?
Oh,
1. That's fine. It's fine. So the points are it's twice as steep. So you go 1 over and 2 down. When you go 2 over, you're going to go how far down? Nope. 8. Remember, it's twice as distance because 2 squared is 4. So here are these 2 points. But it's do you remember that it's symmetric, everybody? If it's symmetric there, can you do the other points? Here and there. So what do you end up with? This. Yeah, that's not bad. So what are those points? Could you make a table if you wanted to? Sure. The values would be -1, 0, 1, and 2. 1, 0, 1, 2, and 3, sorry. We know that when it's 1, it's -3, right? So you plug in, if you wanted to get the rest, plug in 0 into this, what do you get? When you plug in 0 into that, what do you get? -5. So when you plug in 0, you get -5. And is that the point right there? 0, -5. When you plug in -1, what should you get down there? Well, you plug in -1. What's -1 squared? 1. So it's going to be -2 minus 4 minus 5. What's that going to be? Negative what? -11. So what point should this be right here? -1 comma -11. So then you can flip it over. This one has the same y value, but it's at x equals 2. So it's 2 what? 2? Nope. -5. And then this one's 3 what? -11. This is -5 and so could you just make a table? Sure. But it should match. Twice as steep. You should understand what a regular one looks like. So, correct. So what's the vertex? 2, 3. Because why do you know that? This tells you it goes. What does that tell you? Right 2. And what does this one tell you? Up 3. So the vertex is 2, 3. What does this negative sign tell you? Flip over, right? So you flip it. So if you flip that thing, and what does the 4/3 mean? It's going to be steeper than x squared, right? So you put this all together, and you know the vertex is at what, 2, 3? Correct? So the vertex is at 2, 3, which is over 2 up 3. There it is, right there. So I asked you, you know it's going to face down, so you have to make a table, correct? So if that middle, the vertex is in the middle, correct? So the middle value is going to be 2. So what are the other values? I don't know. How about 1 and 0? And how about 3 and 4? We know the vertex is 2, 3. There's your points. So you also plug in 1. Are you going to get fractions?
Yes.
Yeah, you're going to get fractions. What is this thing vaguely going to look like? It's going to look like this. Vaguely. I'm not going to plot the points, but you need to find these values, plot them, and then would you get a curve facing down steeper than what you started with? Yeah, sure. You know, what is it going to be steeper than? If you wanted to graph the thing it's going to be steeper than, x squared is pretty easy. It's going to be here, and it's going to be here. It's going to be here and there. So it's going to be steeper than that, so it's vaguely like this. I'm not very good at the curves, I guess. You got it? So you have to take the time to do it. Is it going to be fractions? Yes. Does it change anything about the work? No. If you factor this, what did it factor into, Kelly?
X plus 3x minus 4.
Correct. So you know that x is equal to -3 or x is equal to 4. Correct. So let's change one thing about this. Let's say I asked you this right here, and I said, where is this greater than 0? A function, a number, a real number, it can be greater than 0, it can be less than 0, or it can be Equal to 0. So what do we know already? What? No, it doesn't. Oh, does it factor it incorrectly? Oh, I see. I didn't do the plus. You're absolutely correct. Thank you. So if I wrote this on a number line right here, where are those two numbers? We have -3 and we have 4. So when x is equal to that, what does f of x equal? 0 and 0. Are there any other places where the function is equal to 0? Oh, come on, have confidence in your work. You just solved this. You found out that when x is equal to -3 or 4, the function is equal to 0. Are there any other values where it equals 0? No. How many times can a quadratic cross the x-axis at the most? 2. Are there any other places? No. No. So what does that mean about all the values between here and here? Can any of them be equal to 0? No. What about the ones right here, the blue region? Can any of them be equal to 0? No. And can any of them be equal to 0 here? No. We found the only places where the function is equal to 0. What happens if I said the function was up here and then it went down there? Is there any way to get from here to here without crossing the purple? No. So is this possible? We found that the only zeros are here and here. Is it possible to have this shape right here? No, because if it did, you have to cross through this purple line. So what does that mean about all the values that are purple? They have to all be what or what? All positive or negative. What about the yellow? They have to be what? All positive or negative. What about the blue? All positive or negative. So if you pick an x value here and plug it into the function, it comes out to 7. What do you know about all of these values? They're all positive. Exactly. What happens if I plug in a number here and it comes out to -5? All of them have to be what? Negative. So if you pick one number, they all have to be, the output is the same sign. The output is the same sign. So let's go back and look at this original, let's look at this new question right here. X squared minus x minus 12 is greater than 0. If we drew that number line right there, we know that there are 3 regions right here. We know equals 0 here. But what about between -3 and 4? It's either all positive or all negative. So let's look at the function. Let's look at this function right here, Rachel. That is the function. We're trying to find out where is it greater than 0. What's an easy number between -3 and 4? 0. Plug in 0 right here. 0 squared minus 0 minus 12. Is that positive or negative? Negative. So what does that mean about the number line? From -3 to 4, what do you know all the values are? All of these have to be what? So all of these are negative. So let's test one to the right. One to the left down here. What's the nicest thing we could try that's on the blue region? -5 or -4, right? Could you test -1 billion if you wanted to? Why don't you want to test -1 billion? It's just annoying. Choose a nice number. Like in here, could we have chosen like 2.9584? But should we? No. So let's choose -4. F of -4 is -4 squared minus -4 minus, are there lots of negatives we have to be careful of? Yeah, it's going to be 16 plus 4 minus 12. What's that? Is 18. Isn't it 18? Right? And we only care if that's positive or negative. What is that? Positive. So what does it tell us here? This is positive. But there's one more region we have to test, right? Over there. What number do you want to test over there? 5. So you just do f of 5. And again, do we care what the actual number is? Not really. We care if it's positive or negative, right? Oh, that's terrible math. It's just plus 4. Thank you. So what should it be? It should be 8. It's the same thing. I'm sorry. You're absolutely correct. So what does this come out to be? 25 minus 5 minus 12. What's that? 8. Is it always going to be the same number? No, it's not always going to be. So what do we know about the yellow region? Positive. So let's answer this question here. I asked you, where is this function greater than 0? Can you tell me where is it greater than 0? Calvin, where is it greater than 0? Less than -3 or what? Greater than 4. That would be your answer right there. X is less than -3 or greater than 4. Can you say and equal to 4? No, because when it's equal to 4, what is it? Is 0 positive or negative? It's neither. It's not either one. So let's say I gave you this one right here. Let's say I gave you a similar one. X squared, let's say, plus 5x minus 6 is less than 0. X squared plus 5x minus 6 is less than 0. See if you can answer that question for me. I'll leave this work right here. Leave that work right there for you. See if you can answer that question for me. X minus 1 equals 0. So it's x is equal to negative 6 or 1. So you made your number line, right? So you have negative 6 and 1. So now you have three regions. You have your purple region in the center. You have your blue region right here. And then you have your yellow region right there. And a little overlap. So you need to pick, what's a good number between 1 and negative 6? 0. Plug in 0 right there. When you plug in 0, what do you get? Negative 6. So this is negative. What happens when you plug in a positive? Let's plug in 2. So f of 2 is going to be 2 squared plus 5 times 2 minus 6. What's that? 4 plus 10 minus 6 is what? It's 8 again, isn't it? So what is it? What's the yellow region going to be? Positive. And what's a number? What number should we plug in there? Negative 8, sure. Negative 8 is fine. So what do you get? Negative 8 squared plus 5 times negative 8 minus 6. What's that? 64 minus 40 minus 6 is what? So what is that? Positive. So I asked you, where is this less than 0, right? So where is it less than 0? Yeah, between negative 6 and, there's your answer right there. Because everything else, what does it come out to be? Positive. The reason it looks like this, everybody, when you graph this function, where does it cross the x-axis? It crosses at 1 and what? Negative 6? What does this function look like? It looks like this. So right here, you see this? That's where it's above the x-axis. Where is it below the x-axis? Between negative 6 and 1. So visually, that's why it's only from here to there. Kind of makes sense? So there's only one little thing to add in. There's only one little thing to add in that makes it slightly more entertaining, and it's the following. And it's not that it makes it more complicated, it's just you have to be very, very careful. Negative 1 over x minus 3 is greater than 1. This right here is not a quadratic. It's not a line either. This is a weird function. What did we do first when I asked you how to solve an inequality like that? We just, instead of having the inequality, what did we turn it into? An equal sign, right? So let's say if we wanted to answer this question, the first thing, don't write anything down, everybody just watch, equals 1. Hey, we can solve that, can't we? What should I multiply both sides by, Rourke?
X minus 3.
So you negative 1 is equal to x minus 3. Add 3 to both sides, and what do you get? 2 is equal to x. So we have our number line, and what's the only number we get to put on it? 2. So how many regions do we have? We have a green region, and let's say a purple region. So let's look at this original equation right here. What number is to the left of 2? That's really nice to plug in. So 1 over 0 minus 3, is that greater than 1? Really? Oh, it's negative, thank you. Yeah, it is. So this is what? Positive. What's a number to the right of 2? Let's plug in 3. Negative 1 over 3 minus 3. What's the problem? You can't divide by 0. So can you tell me, why did we pick that 2 there? Can someone tell me why that 2 got on the list? It's the only solution when you make it equals. There's another set of numbers that you have to put in. This function right here, you see this function? What's the domain of this function? X such that can equal 3. On this number line, you also have to put on any numbers that are not in the domain. So you have to make it equal and check which numbers are not in the domain. So can we plug in 3? No, you can't plug in 3. So can you give me a different number I should plug in? Plug in 4. Negative 1 over 4 minus 3. Is that greater than 1? You have negative 1 over what? Is that greater than 1? Oh, it's just 1. I'm sorry. Is it? No, it's not, right? Because that's negative. So this is negative right here. What's a number between 2 and 3? 2.5? So you're with me so far? Is everybody okay so far? Oh, by the way, hold on. We need to check something here. I asked you if this is true. What is negative 1 over negative 3? No, it's 1/3. Is this true? Is 1/3 greater than 1? So it's not true here. It's not true. Over here, because we're dealing with 1 instead of 0, is this true? We already said, is that true? Is negative 1 greater than 1? No, it's not true, so it's not true. Possible, only we haven't checked it yet. We're not guaranteed to have a solution right now. It could be that there are no solutions, okay? So let's check what's in between 2 and 3. We have to use a fraction, right? So 2.5. What about this one? 1 over 5 over 2 minus 3. Is that greater than 1? Let's check. How many halves are there in 3? 1 over 5 over 2 minus 6 over 2. Is that greater than 1? Well, what's 5 over 2 minus 6 over 2? What is it? Oh, it's negative, sorry. Negative a half. Is that true? What's 1 divided by negative half? 2. Is that true? It is true. So, what's the only part that is true? This is true. So what's the answer to this? X is less than 3 and greater than 2. So these numbers, the biggest battle by far, everybody, the biggest battle of finding these numbers. Why did we use 2? Because it's what makes the equation true. And what about 3? Where did that come from? Not in the domain. And the only thing you have to watch out for the domain is dividing by 0. It's like negative 1 over x. Oh, it's 3. So how many regions do you have? 1, 2, and 3. And we're not testing positive or negative here. We're testing greater than what? 1. So in this case, this was equal to 1/3, right? 1/3 is not greater than 1, so not true. Not true, true. So what's the answer? X is less than 3 and greater than 2. Does that kind of vaguely make a